Okay, so let's look at the equation of f of x equals 2x minus 1 squared. So in this video, we're continuing with quadratic equations in standard form. And notice that this equation is not in standard form, so we must put it in standard form before. So you should not be defining or identifying your coefficients from this form of the equation, because it won't work and they won't be correct. Okay, so let's go ahead and multiply this out. So we have 2, and then open the big brackets, x minus 1 times x minus 1, and then close the big brackets. So then we end up with 2, and then inside the brackets, remember, we can FOIL it out or box it, so whichever suits you. First, outer, inner, last. So that's going to be x squared minus x plus 1. And then when we multiply it out, first let's simplify it. So 2 times x squared minus 2x plus 1. And then the final one is 2x squared minus 4x plus 2. Okay, so that's our final standard form. F of x equals 2x squared minus 4x plus 2. Okay, so what we want to do is now find the axis of symmetry. So x is equal to negative b over 2 times a. So now we can go ahead and identify our coefficients. A is 2, b is negative 4, and c is 2 also. So negative 4 divided by 2 times 2 will give me a positive 4 divided by 4, which is 1. Okay, so our axis of symmetry is 1. Let's go ahead and graph that. At least this one's a nice whole number, so we don't have to do too much interpreting in order to find it. Okay, so now let's use the axis of symmetry in order to find the vertex. Okay, so our vertex, remember, is going to be 1 comma whatever that y value is there. Okay, so f of 1 is equal to 2 times 1 squared minus 4 times 1 plus 2. So in that case, it'd be 2 minus 4 plus 2, which would be 0. So f of 1 is equal to 0. You could also try it in the other form. It'll still work by plugging in the equation, but of course you won't be able to get the coefficients which you need to find other things. But if you did, so f of 1 equals 2 times 1 minus 1 squared, which would be 2 times 0, which would be 0. Okay, so it looks like our vertex is on the point 1 comma 0. So let me graph that, 1 comma 0. Okay, so now let's find our y-intercept. Well, we put our equation in standard form, so we actually can look at c. So c would be this value here, the plus 2. So c is 2. Therefore, or this value here, which we already identified, therefore our y-intercept is 0 comma 2. Okay, so 0, 1, 2. Okay, so there's our y-intercept there. And remember that we can go equidistant on the other side. So this one is 1 away from the axis of symmetry. So 1 away from the axis of symmetry on the right side will also give us a point at the same y value. Okay, so now let's find our x-intercepts. It looks like we've identified one of them, but let's make sure that's the only one. So we're going to use b squared minus 4 times a times c. And so that would be, b squared would be negative 4 squared minus 4 times 2 times 4. Oops, sorry, times 2. C is 2. So AC is 2 times 2. So that's going to give us 16, and 4 times 2 is 8, times 2 is 16. So 16 minus 16 is 0. So if b squared minus 4ac is equal to 0, so that means we have one x-intercept. So let's find out what it is. So x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Remember, we just found the discriminant, so x equals negative 4 plus or minus the square root of 0, which we just found the b squared minus 4ac to be, plus 2 divided by 2 times 2. And so that gives us x is equal to a positive 4. And then this plus or minus 0 will just become 0, so we don't need to rewrite that, divided by 4. So we only have one option for our answer, and that's at the x value of 1, which we've already identified, 1 comma 0. So if you wanted to find more points up here, you could find them by plugging them in. Like for instance, if you wanted to find out what was happening at 3, you just plug it into the equation. So we can do that, and we only need to find 1 point. The only reason I'm finding 3 is because I have my x-intercept, which also serves as my vertex in this case. So that is the point 1, 0. I have my y-intercept, which is 0, 3. I'm sorry, 0, 2. And so if I wanted to find another point, then I just take any point that I wanted, any x value that I wanted, and plug that into my equation, and that will work. So f of, let's say, 3, we want to know what's happening at 3, is going to be equal to, of course I need my equation in order to do this one. So remember, you can use either equation to plug in 3, but let's use the one we transformed. So 2 times 3 squared minus 4 times 3 plus 2. So that's going to be 18 minus 12 plus 2. And so 18 minus 12 is 6 plus 2 is 10. And so at 3, 10, which is way up off my graph, it's going to be somewhere way up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be way up here. And then on the other side, we'd get the same thing. And so my parabola will actually look like this. Okay, so that is my parabola, and I have my important point. So if you can only find 3 points, then make sure you label them all. And this point is 2, 2. All right, so I hope this video has helped, and let's determine whether this is a maximum or a minimum. In this case, we can clearly see that the vertex is the lowest point, so this makes this a minimum at 1, 0. So we have one x-intercept because our vertex sits on the x-axis. All right, I hope this video has been helpful. The more you practice, of course, the better you'll get at this. I know it may be tiring, but just press through and just be careful of little weary mistakes. All right, thanks.